हेलो फ्रेंड, गुड मॉर्निंग एवरीवन। आज हम लोग एक प्रॉब्लम देखते हैं सीक्वेंस एंड सीरीज ऑफ फंक्शन का। लेट्स सीक्वेंस bn and sequence cn be the sequence of real number. Necessary and sufficient condition for the sequence of polynomial fnx equal to bnx plus cnx square to converge uniformly to 0 on the real line is, and option is like limit of n tending to infinity bn equal to 0 and limit of n tending to infinity cn equal to 0. क्वेश्चन क्या कर रहा है कि सीक्वेंस एन बी सीक्वेंस ए एन बी एन एंड सी एन बी सीक्वेंस ऑफ रियल नंबर. Then we have to find the necessary and sufficient condition for the sequence of polynomial fnx equal to bnx plus cnx square to converge it uniformly to 0. That means sequence fnx अगर uniformly convergent to 0 होगा, then what is the sufficient and necessary conditions? तो हम लोग देखते हैं फर्स्ट ऑप्शन को. फर्स्ट ऑप्शन में है कि लिमिट ऑफ n टेंडिंग टू इन्फिनिटी bn इक्वल टू 0 एंड लिमिट ऑफ n टेंडिंग टू इन्फिनिटी cn इक्वल टू 0. सपोज bn इक्वल टू 1/n and cn इक्वल टू 0 for all n belongs to natural number. Then bn is tending to 0 as n tending to infinity. bn is tending to 0 as n tending to infinity, and cn is tending to 1 minute. Okay. bn is tending to 0 as n tending to infinity, and cn is tending to 0 as n tending to infinity. Then fx equal to fnx equal to bnx plus cnx square, which is given in the question, and it will be x bata n, which is tending to 0 as n tending to infinity for fixed x belongs to real number. Sequence fnx converge pointwise on R because the limit of fnx is 0 as n tending to infinity. That's why we can say that the sequence fnx converge pointwise on R. But sequence fnx is not uniformly convergent by Mn test, and now I write the statement of Mn test. Okay, 1 minute. Okay. Mn test. Let sequence fnx be a sequence of real valued function defined on D. And fn converges f pointwise. On D, and define Mn equal to supremum of mode of fn x minus fx such that x belongs to D. Then sequence fn x converge uniformly if and only if mn tending to 0 as n tending to infinity. This is a mn test. Okay. By mn test we can easily see that sequence fn x equal to x bata n. Here sequence fn x equal to x bata n is converging pointwise but not uniformly convergent, because this sequence is increasing sequence, and if you put x is equal to n, then this tending to 1, that means mn tending to 1 as n tending to infinity, not tending to 0. That's why function fn x is not uniformly convergent, only pointwise convergent. But in question we have to find necessary and sufficient condition. Okay, we have to find necessary and sufficient conditions, but this sufficient condition is not satisfied. If this condition is satisfied, then sequence fn x not converging uniformly to 0. That means this option is wrong. Okay, and see second option, sigma mod of bn is less than infinity, sigma mod of cn is less than infinity. For option B, let bn equal to 1 bata n square and cn is equal to 0. Sigma mod of bn is convergent by p test. P test means sigma 1 bata n to the power p is convergent if p greater than 1, divergent if p less than equal to 1. By p test you can say that sigma mod of bn is convergent and sigma cn is convergent. Sequence fn x equal to x bata n square, because cn equal to 0, that's why fn x is equal to x bata n square tending to 0 and tending to infinity. But here also sequence fn x not converges uniformly, because sequence fn x is increasing sequence and this sequence is not tending to mn not tending to 0 as n tending to infinity. That's why by mn test this sequence fn x is not uniformly convergent. That means option B is also wrong. Now see on the next option. Option C, there exists a positive integer n naught. There exists a positive integer n naught such that bn equal to 0 and cn equal to 0 for all n greater than equal to n naught. That means for large n, there exists a large natural number such that bn equal to 0 and cn equal to 0. This is a necessary and sufficient condition we have to show. Okay. Now see option C, necessary part. In necessary part, suppose if either of bn a cn is non-zero for at least one n greater than n, let bn equal to c not equal to 0 for all n belongs to natural number and cn equal to 0 for all n belongs to natural number, and x is equal to 1 bata c. Then fn x is equal to c times 1 by c equal to 1, which is tending to 1 as n tending to infinity, which is not tending to 0, as n tending to infinity. Okay, 1 minute. Which is not tending to 0 as n tending to infinity. That means sequence f and x is not uniformly converging to 0. Sequence f and x is converging uniformly to 0. Therefore, if you choose, if there exists a constant which is not 0, then sequence f and x is not uniformly convergent. That means what? If sequence f and x converge uniformly to 0, then there exists a positive integer n naught such that bn equal to 0 and cn equal to 0 for n greater than or equal to n naught. Now see the sufficient part. Sufficient part, suppose there exists a integer n naught. There exists a integer n naught such that bn equal to 0 and cn equal to 0 for all n greater than or equal to n naught. Then fnx equal to 0 for all n greater than n naught implies sequence fnx uniformly converging to 0. This means uniformly convergent. Uniformly convergent to 0 as n tending to infinity. That means option C is correct. Okay. And option D. For option D, Cn equal to 0. C in option 1. Option 1 Cn equal to 0 and Bn is equal to 1 by n. Then this sequence f and x is not uniformly convergent. That means option D is also wrong. And only option C is correct. Okay. If you have any doubt, then comment on the comment box. Thank you. Okay, bye bye.